far we have seen how to, what is empirical formula and what is molecular formula, and we have also seen how we can determine these two different types of formulas. In order to find out empirical formula, we definitely need the percentage compositions, and in order to find out the molecular formulas, we definitely need the empirical formulas. So they're like interconnected with each other. It's like a connection. Okay, so now let's see that what are the major differences, or how how the molecules differ from empirical formula and molecular formula. So here is some examples. So these are the empirical formula and these are the molecular formula of the same compound. So see, the empirical formula for carbon dioxide and the empirical molecular formula for carbon dioxide, they are same. The empirical formula for water and the empirical molecular formula for water, that's also same. The empirical formula of nitrogen dioxide and the molecular formula is not same. See, they're not same. This is basically tetranitrate, tetradienitrate. Okay. Over here, the empirical formula and the molecular formula are not same, and over here they are not same as well. So in the three cases over here, the empirical formulas were different from the molecular formula. Okay. So now let's see another one. Let's see a difference which is more precise, and that is, this is the empirical formula. See, empirical formula basically represents the least amounts of the least amounts of the least amounts of elements that are present in there. But the molecular formula actually gives you the entire idea about how many elements are present, or in which amount, obviously. See, in the empirical formula, we got to know that we have only one carbon, but over here we have 1, 2, 3, 4, 5, and 6 carbons. See, that's where the empirical formulas and molecular formulas are different from each other. This is basically representing the simplest ratios of these elements, but this is basically representing the entire amount of the elements. Okay, so now we're going to be seeing how actually we can do a reverse process. So in order to find out the molecular formula, we need the empirical formula. We use the empirical formula and we get the molecular formula, right? So if I tell you that there's a reverse way that you can get the empirical formula from the molecular formula, would you believe me? I don't think, I don't know, maybe you would or maybe you wouldn't, but what I said is exactly correct. You can actually reverse the process and you can use the molecular formula to find the empirical formula, and the process is very easy. All you gotta do is write the molecular formula. Say, for example, I'll be writing C6H12O6. This is the molecular formula of glucose, right? And then what I'm gonna do is I'm gonna write the ratio of the carbons, hydrogens, and oxygens. I'm going to be writing like that. So what is the ratio of how many carbons are present in here? 6 carbons. How many oxygens? Sorry, how many hydrogens? 12 hydrogens. How many oxygens? 6 oxygens. So what we have to do is we have to find out, or we have to get the simplest ratio possible out of these numbers. So if we divide them with 6, then we get 1, 2, 1, right? So this is the simplest. We cannot decompose it anymore. This is the simplest that we get, and if we use according to that, then we get CH2O. And previously we have seen that this is the empirical formula of what? This is the empirical formula of glucose. Okay, this is the empirical formula. So we can actually get the empirical formula from the molecular formula. See, the process is very easy, not as lengthy as the processes we have seen before when we were finding out the molecular formula. Okay, if you have understood this whole thing, I'll be clearing it and I'll be giving you another example. Okay, let's give you another example. Okay. So let's take another substance, or let's say what we're gonna take. Okay, let's take acid. Say, for example, HNO3. Okay, so this is the molecular formula of nitric acid. So let's do the ratios. So how many hydrogens are present here? 1. How many nitrogens are present here? 1. How many oxygens are present here 3. So are they divisible with any number? No, they're not divisible. They're obviously divisible by 1, but that doesn't count. Okay, dividing something with 1, just, it doesn't change anything actually. So this is the simplest ratio possible. Okay, so the empirical formula would be same as the molecular formula. So previously I have mentioned about it to you guys that there are some cases where the empirical formula and the molecular formula is same. So in this case that happened. The same can go for water and carbon dioxide and sulfuric acid as well. For these substances or these chemical compounds, the molecular formula and the empirical formula, they remain exactly same. Okay, so it's very easy to find out the empirical formula from molecular formula. It's basically a reverse process, very easy. Okay,